Simplifying radical expressions. In this lesson, you will learn to multiply and simplify radical expressions, and you will learn to divide and simplify radical expressions. Note that radical 4 times radical 25. Radical 4 is 2, radical 25 is 5, so 2 times 5 is 10. And also radical 4 times 25 is the same as radical 100 equal to 10. Likewise, another example here, third root of 27 times third root of 8 is equal to 3 times 2 equal to 6, and also third root of 27 times 8 is equal to third root of 216 equal to 6. These examples suggest the following rule: the product rule for radicals. For any non-negative real numbers a and b and any index k, kth root of a times kth root of b is equal to kth root of a times b. The index here must be the same. The index must be the same. So to multiply here, we need only to multiply radicals. So for example, radical 3 times radical 5, here the index is 2 and the index here is 2, so same index, so we can keep the root and multiply only radicals. So 3 times 5, it will be square root of 15. Another example, third root of 4 times third root of 5. So here we have the same index, so we can keep the root and multiply radicals. Another example, square root of 5a times the square root of 2b. Same index, so we have to keep the root and multiply radicand. So we will multiply 5a by 2b, it will be square root of 10ab. Another one, fourth root of y over 5 times fourth root of 7 over y. So here we have fourth root, so fourth root, keep the root, and then multiply y over 5 times 7 over y, and we can simplify here y with y, so it will be fourth root of 7 over 5. Okay, now your turn. Multiply fourth root of 3p times fourth root of 7q. Another one, third root of 5 over p times third root of 2 over q. Keep in mind that the product rule can be used only when the index are the same. When the index differ, we can use rational exponent as we did in section 6.2. Like what? For example, here multiply radical 5x times fourth root of 3y. Here, the index here is 2, but the index here is 4, different index. So we have to convert into exponential exponent. So converting to exponential notation, it will be here 5x to the power of half times 3y to the power of 1 over 4. Now we need to change denominators to be the same. So here 1 over 4 multiplied by 2 multiplied by 2, it will be 5x to the power of 2 over 4 times 3y to the power of 1 over 4. Here we have same denominator, so we can take it as common. So we have here 5x to the power of 2 times 3y all to the power of 1 over 4. 5 to the power of 2 is 25. X to the power of 2 times 3y all to the power of 1 over 4. Let's continue. So here, multiply number by number. 3 times 25 is 75 x squared y all to the power of 1 over 4. Now we can convert rational exponent into radical. So the index will be 4. It will be fourth root of 75 x squared y. Now your turn. Multiply fourth root third root of 2y times fourth root of x. Factoring rational expression, radical expression for any non-negative, for any non-negative real numbers a and b and the index k. Kth root of a times b, here we can distribute the root. So it will be kth root of a times kth root of b. Now let us compare the following. Square root of 50 is the same as square root of 5 times square root of 10. And square root of 50 also is the same as square root of 25 times square root of 2, because 25 times 2 is 50. And we know that we can simplify square root of 25 as 5, so it will be 5 radical 2. So here the best way to simplify radical expression now here is to factor the radicand into prime factorization. So first example here, simplify by factoring. Third root of 32 if you don't know, you can factor using prime factorization. 32 here is 4 times 8. 4 is 2 times 2. 8 2 times 4. 4 2 times 2. Here are the prime factorization. So we can rewrite as third root of 8 times 4. And now we can distribute third root, so it will be third root of 8 times third root of 4. Third root of 8 is 2, third root of 4. Another example, fourth root of 48. So we need to find here two factors. One of them we can find fourth root of it, as we learned here 48. So we can factor it as 6 times 8, and 8 2 times 4, 2 times 2, 6 is 3 times 2. So here we have 4 2's. That means we can rewrite it as fourth root of 16 times 3. So fourth root of 16 is 2. Fourth root of 3. Another example, square root of 5x squared. Here we can distribute square root as square root of 5 times square root of x squared. Must be 5 absolute value of x. But I said before here x represent non-negative. So we can write it without absolute value as 5x. Okay, here if we have another example here, square root of 18 x squared y. Now we need to look for perfect square factors. So we can write 18 as 9 times 2, because 9 here is a perfect square, and we have here x squared as a perfect square. Now let us rewrite it again here as square root of 9 times 2 times x squared times y, and distribute square root here. It will be square root of 9 times the square root of 2 times the square root of x squared times the square root of y. So equal here 3, and we couldn't find the exact value of the square root, so we'll keep it, and then square root of x squared as x is non-negative real number, so it will be x. And now we have a square root of 2 times the square root of y, and we can multiply here, so it will be 3x square root of 2y. Another example, square root of 216 x to the power of 5 y to the power of 3. So now we need to look for perfect square factors. So look for perfect square factors. So here we have here 216 as 36 times 6, and we have here x to the power of 5 means x to the power of 2, x to the power of 2, x to the power of 1, y to the power of 3 means y to the power of 2, y to the power of 1. So here we can find factor square root of each one of them. Now square root of 36 is 6. Square root of 6 we have to keep it. Square root of 6. Square root of x squared is x. Square root of x squared is x. The square root of x we keep it as square root of x. Square root of y is y, and here keep square root of y. Now we can multiply, so it will be 6x squared y times square root of 6x y. Another way to solve this, if you don't know how can you find perfect square, is to factor completely to 116. You can factor completely here to 116. How can you factor it completely using prime factorization? So 216, if you don't know, you can divide here by 2, so it will be here 108, and then you can divide 108 by 2 if you don't know, so it will be 54, and we know that 54 is 9 times 6, 9 is 3 times 3, and 6 is 2 times 3. So for each 2 here, for each 2 factors, we represent perfect square. So here, these 2 factors represent perfect square. So we have 4, we have here 9, and we have 6. And the square root of 4 is 2, the square root of 9 is 3, 2 times 3 is 6. Okay, now your turn. Simplify. Square root of 27 ZW square. Okay. Now, if I have here third root of 16 a to the power of 7 b to the power of 11. So now the index here now is 3. So we have to look for perfect cube, not perfect square now. So perfect cube, that means here 16 is 8 times 2, and a to the power of 7 means a to the power of 6, and times a, b to the power of 11 represent b to the power of 9 times b to the power of 2. So let us rewrite it again as third root of 8 times 2 times a to the power of 6 times a times b to the power of 9 times b to the power of 2. Now, third root of 8 is 2, third root of 2, so we will keep 2 here inside the radical expression. Now, third root of a to the power of 6 is a to the power of 2, third root of a, keep a under the radical, third root of b to the power of 9 is b to the power of 3, and we can keep b, so we have here third root of 2 a b to the power of 2. Now your turn. Simplify. Third root 81 x to the power of 4 y to the power of 8. Okay, now here second part of our lesson is dividing and simplifying radical expression. Dividing and simplifying radical expression, we can use dividing and simplifying as multiplying and dividing under the same conditions. So we must have the same index. We must have the same index. So kth root of a over kth root of b is equal to kth root of a over b, such that b is not equal to 0. And we vice versa. That means here kth root of a over b, now we can distribute. So it will be kth root of a over kth root of b. For example, 5 third root of 32 over third root of 2. Now here we have same index, so we can keep here 5, and we can keep the same root. 32 divided by 2 is 16. Now third root of 16, so we have to find perfect cube as 8 times 2, so it will be 5. Third root of 8 times 2, third root of 8 is 2. Third root of 2, 5 times 2 is 10. Third root of 2. Another example. Third root of 27 over 125. So we can distribute the root here, so it will be third root of 27 over third root of 125, and we know that third root of 27 is 3, third root of 125 is 5, so it will be 3 over 5. Another example, square root of 16 x cubed over y to the power of 4. So we can distribute here square root over each term. So it will be square root of 16x to the power of 3 over square root of y to the power of 4. Now here we have to distribute the square root over each term under the radical. Square root of 16 is 4. Square root of x to the power of 3, as we said before, we have to look for perfect square, so x squared times x, square root of x squared is x, and we keep x under the radical, and square root of y to the power of 4 is y to the power of 2. Another example. Third root of 27y to the power of 5 over 343 x to the power of 3. Now we can distribute the root, so it will be third root of 27y to the power of 5 over third root of 343 x to the power of 3, and we know that we have to look for perfect cube. Look for perfect cube. So here 27 cube root of 27 is 3 cube root of y, so we can write y to the power of 5 as y to the power of 3 times y to the power of 2. Third root of y to the power of 3 is y, and we can keep y to the power of 2 under the radical, and we have here third root of 343 is 7, and third root of x is x to the power of 3 is x. How can we divide if we don't have the same index? So we have to convert, like what? Here third root a square b to the power of 4 over square root of ab. So we have here to convert into what? Into radical, into exponential notation. So it will be a square b to the power of 4 all to the power of 1 over 3 over ab all to the power of 1 over 2. Now we have to change both denominators to be the same, so we can multiply here by 2, multiply by 2, multiply by 3, multiply by 3. Now we have a to the power of 2, b to the power of 4, all to the power of 2 over 6 over ab all to the power of 3 over 6. Now we have same denominator, so we can take it as a common, equal to a squared b to the power of 4 all to the power of 2 over ab all to the power of 3 all to the power of 1 over 6. Now we can simplify. So here equal to a to the power of 4, b to the power of 8 over a to the power of 3, b to the power of 3, all to the power of 1 over 6. Now we can divide a to the power of 4 over a to the power of 3 is a to the power of 1, b to the power of 8 over b to the power of 3 is b to the power of 5, all to the power of 1 over 6. Then we convert it into radical again. So 6th root of a b to the power of 5. Now your turn. Simplify. Square root of x squared over 100. Third root of 54 x to the power of 5 over 125. And the last one, divide and simplify. Fourth root of x to the power of 3 y to the power of 2 over third root of x squared y. Thank you guys and goodbye.